All right, so I want to talk about how I have things laid out on the Moodle page. It's still a work in progress, but the introduction section here, which is the first thing that it's going to open up, hopefully every time you go in, has a link for our Zoom meetings. And so for the Zoom meetings, if you want to attend in person, assuming you're not expressing any symptoms of COVID-19 or anything like that, you're more than welcome to do so. But if you need to quarantine, or you feel sick, or you just really don't want to wear pants that day or whatever, the option is available to attend the class virtually. I'm not going to force you guys to come here, even if you're asymptomatic. Effectively, you're adults. It's your option to choose to physically or online, should you choose to do. I think it will be of more benefit to you if you actually attend the class physically, but I'm not going to hold against you if you choose not to do that. I also have a Zoom link for my office hours. All of my office hours are held online because I don't want you guys coming into my office and germing it all up. So my office hours are Monday, Wednesday from 12:30 to 5 p.m. So immediately after this class until close of business. And then on Friday, it's kind of hard to see, but it's 12:30 to 2 p.m. And that information is also on the syllabus. I have the little announcement thing here. That's just whenever I send out an email to the entire class, that's what I do it from. Then we have the syllabus, a homework formatting example, which will be referenced in the syllabus. And then you guys will need to have MathCAD installed. Here is the link to a Google form to get access to MathCAD Prime 6.0. It's my preference that you use MathCAD Prime as opposed to MathCAD 15, mainly just because a lot more students seem to use Prime, so I've switched over to that. And it'll make my life easier if you're asking questions about how to use it if everybody uses the same version. If you have MathCAD 5 or MathCAD Prime 5 or MathCAD Prime 4.0, depending on what year you got here as a freshman, those are all good too. If you've had to, reformat your computer, blah, 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 this is an opportunity for you to re-download that and use it, because we will use it extensively in this class. Another software package that we will be using is LT Spice. LT Spice is a circuit simulation tool created by the company Analog Devices. And we're going to use that a lot in some of our design problems, as well as verifying that our analytical solutions to some of our problems are correct. Excuse me. The next link there is an LT Spice overview. That's just kind of telling you about the functionality and all that kind of stuff. And then the link after that are some tutorials. So your ability to use LT Spice in this class is what we would consider, and by that I mean it's part of the ABET assessment for this class, a lifelong learning initiative. What that means is the burden of learning how to use LT Spice correctly to succeed in this class is on you, not on me. So you are expected to use the internet and things like that to learn how to do the different functions. I'm not saying I'm not going to answer any questions, but I am saying I'm not going to sit here and give you guys an in-depth tutorial every time I expect you to use it. You're going to have to show some initiative and do some of your own work. All right, so let's circle back around to the syllabus. Pretty basic boilerplate stuff. I'm Dr. Hartman. My office is upstairs. You can't come in it. That's why I have the online office hours. There's my email address. I'm trying to be more responsive to student emails because I've got some, I don't want to say complaints, but some snarky messages about how I don't check my email often enough. All right, so first thing, emergency class disruption policy. Let me zoom in on this guy a little bit so you can see it a little better. If we have to go to fully online because of the COVID-19 getting worse or whatever, everything will be done via Moodle and Zoom, which is why I already have the Zoom link and all that kind of stuff set up. The course objectives, we are going to take what we learned in 221 and ramp everything up a notch. a notch. In 221, we went over a multitude of topics with a very shallow level of detail. We're going to focus in this class really on, I think, 4 broad topics. We are going to cover op-amps for like 6 days instead of 2, and we're going to get really into the nitty-gritty of how op-amps behave. We're going to talk about open loop op-amp circuits, positive feedback circuits, negative feedback circuits, and cascading them by chaining them together, all that kind of good stuff. We're not going to be limiting ourselves to simple DC circuits that are all negative feedback. We're really going to explore how op-amps can be used in a variety of applications. Then we're going to move along to RLC transient analysis. So in circuits 1, you guys did RL and RC, or first order transient analysis. We're bumping things up to having 2 energy storage elements in C's and seeing how that affects our transient response and all that kind of good stuff. The third module, as it were, is really a review of the steady state sinusoidal circuit analysis that you learned in circuits 1, with maybe a bit more in depth about multi-frequency circuits and things like that. Largely it's review because in my experience, circuits 1 students, once they pass exam 1 and exam 2, tend to check out on all the new material because they figure they can pass the cumulative final. And so I have to waste 2 weeks of time going back over everything so that you don't fail all your subsequent classes. And then the 4th module is on polyphase circuits, specifically 3-phase power systems and stuff like that. So that's what we're going to be talking about in this class. Officially, the textbook is Engineering Circuit Analysis, 9th edition by Height, Kimmerly, and Durbin. It's a good enough textbook. Really, any circuit analysis textbook will do. With that in mind, if you go to Google and you type in CAD Ulabi, might not have put enough L's in there. Nope, I did. The first thing that shows up is an online textbook by Fawad Ulabi, Cynthia First, and Michael Maharbis. This is free. It's got all the same material as the textbook you're being asked to pay for, except in my opinion, it explains 3-phase circuits a whole heck of a lot better. So I would encourage you to download this instead of the one that's sold in the bookstore. So screw McGraw-Hill out of 130 bucks or whatever. I don't care, they don't pay me, so whatever. But any circuit analysis textbook that you can get your hands on, regardless of edition, should really be good enough for this class. So it really doesn't matter what you get. All right, disability disclosure. If you need special testing or classroom accommodations, contact Testing and Disability Services over in Wiley Tower as soon as possible, and then let me know what I need to do to accommodate you. Class attendance, we've already talked about to some extent. Officially, it's what it says in Chapter 3 of the bulletin. Unofficially, you are adults. You or your parents or the government or somebody is paying for you to be in this class. If you choose to be here, that's great. If you don't choose to be here, I'm not gonna do anything really about it. Your choosing not to be here will be enough of a punishment when you see your grades. So that's good enough for me. I don't need to be more of a jerk on top of that. Academic misconduct, a bunch of stuff from the official Chapter 4 of the bulletin. Generally speaking, don't cheat and be less of a jerk than I am, and you'll do great in this class as far as academic misconduct goes. All right, homeworks. There are going to be roughly 20 homeworks in this class. Seems like a lot, it is, but you need to know this stuff because this is the real foundation of everything that you're going to be learning in your power electronics class, in your communications classes, in your signals and systems classes. This is the real start of your EE career. So I force you to practice a whole heck of a lot. Let's see. All of your homework is to be submitted electronically. So let's take a side note here. Right here, I have a homework formatting example. I want the homeworks formatted in this exact way. And if you don't do it in this way, I'm going to delete it and make you resubmit it. So let's talk specifically about what I want. So this is an old homework one from a couple of years ago. This is my solutions guide, and it is done in the format that I want it, okay? So the first page or pages are the assignment sheet, okay? So all of the problems that I assign to you, your assignment sheet is effectively your cover page. So I assigned, good God, 6 problems. I think I've set a personal limit now of only doing at most 5 problems per homework set. But anyway, so the homework assignment sheet itself is the cover page or cover pages. Then I want handwritten work for problem 1, okay? In proper engineering format, meaning you write out the problem statement, then you start providing your solution. Here's problem 1 work, more problem 1 work, more problem 1 work, more problem 1 work. All right. Then, if solving the problem requires the use of a computer algebra tool like MathCAD or Wolfram Alpha, but I would very much prefer MathCAD. In fact, on your exams, the take-home portion of your exams, which we'll talk about in a little bit, I will specify explicitly use MathCAD to do X, Y, or Z. So all of your MathCAD work for problem 1 should show up next. If the problem also requires the use of LT Spice or circuit simulations tool, you would also append that to the end of the work for that particular problem. Then here's the work for problem 2, computer work for problem 2, then problem 3, computer work for problem 3, problem 4, computer work, etc. Does anybody have any questions about the expected format for this? So it's assignment sheet, which is the cover pages, handwritten work for problem 1, computer work for problem 1, handwritten work for problem 2, computer work for problem 2, etc. What's up? Yeah, I got no problem. Yeah, you do not have to, it does not have to be on paper. You can absolutely do it on your tablet. Like I have a program that allows me to edit PDFs, and so my background for that is engineering paper, so that I can do all that kind of stuff. That's how I'm going to give you the notes in this class. So I can't do that and then tell you you can't do it. I guess that would be too much of a jerk of me. So I want you to submit your homework assignments as a single PDF file. If we circle back over here and we look at where it says Circuits 1 review materials, your first homework assignment is already posted. It is literally, let me see what the Race is saying in the chat. Will we have to rewrite the problem statement by hand for each one, or could we have that part printed with work by hand? I would prefer that you rewrite it, but I'm not gonna go nuts if you make a copy of it and do that kind of stuff. You have that ability with computers and technology, so that's fine by me just copying it down. But I went through the trouble of handwriting it, so whatever. All right, so if we go to this online submission portal right here, it tells you the exact format of the file I want. So I want your last name, comma, first name, ELEN 223, winter 2021, and then homework 1. Non-PDF files will not be accepted, meaning I literally have this thing configured to where if you try to submit something that isn't a PDF, you cannot upload it. So I want everything done as a single PDF. Have I made myself abundantly clear of what my expectations are? I know you may think I'm an ass for going over this over and over and over again. There's 11 of you. I guarantee you 3 of you will screw it up before this is due next Wednesday. Guarantee it. So, all right. Let's circle back around to the syllabus. Here we go. All right, so homework assignments are due at 5 p.m. 1 week after they are assigned. So I don't want, all of your homework assignments are to be submitted electronically. Do not bring me a paper assignment. I will put it in the trash can. They're due at 5, which means you have roughly a week and 4.5 hours to get each assignment done, which means I really don't care if you have some internet failure or this, that, or the other, and you can't get it submitted online. That's your problem, not mine. I gave you plenty of time to turn it in, okay? Unless I get a message from the IT department here at Tech saying Moodle was down when this thing was supposed to be due, it's your problem to get it submitted on time, not mine. As far as I'm concerned, each homework assignment should take roughly 2 to 2.5 hours, which means I've given you a week of time to procrastinate to get it turned in. All right, have I made myself very, very clear about that? So I don't want, oh, Dr. Hartman, I forgot this or I forgot that. Don't care, don't want to deal with it. Late homework assignments will incur a 20% penalty for each day that they're late. So when you turn in your homework assignment, it tells me how much it was early or how much it was late. So it's pretty easy to see. So if it's between, 1 minute and 24 hours late, you get 20% off. 24 to 48 hours, et cetera. It's really easy for me to tell how late it is because of the online submission thing. All right, design projects. As part of this course, students will be given a selection of practical problems to solve and must successfully design and simulate a circuit to meet the needs of the given scenario. To successfully complete each project, students will be required to submit a SPICE simulation code file and a written report. And I will give you guys an example written report or whatever for it too, so that you'll know exactly what to do and how to follow it and all that kind of stuff. If you fail to complete all design project assignments, you will get an F in this class. So while these are only worth 10% of your grade, if you choose not to do them, I will fail you, okay? The reason I'm going with such a strict policy is because I used to give these design problems as a homework assignment, and then over half the class would just say, well, screw it, homework's not worth that much, so I'll just skip them. And I use this for ABET assessment and to be able to test your skills for critical thinking, and also whether to recommend you towards internships and things like that. Your ability to actually do real engineering work and not just regurgitate classroom crap is important. So I'm trying to break you of that habit of, what equation do I apply to get this done, and make you think more about what do I know and how can I apply that to meet a specific set of criteria, because that's what your employers are going to be looking for. Okay? I run an internship program for a manufacturing plant out of Bossier that hires, probably 4 to 5 EE students, usually over the summer, but some students we like enough, we keep them on all year. And so I use this class as kind of a weed out to see who I would be interested in having work for me for, around 20 bucks an hour while they finish their degree, and get real practical experience working with engineers from, Samsung and Nextera and all that kind of stuff, along with me and our crew over at Sabre. So I take the critical thinking aspect of this class very, very seriously. All right, exams. There will be 3 exams given during this class. Each exam will consist of a closed book and closed notes portion to be completed during the class time. It is worth 70% of the exam grade. And then there is an open book, open notes portion to be completed outside of class. And I'll give you roughly a day or 2 to finish that up. It'll be like 3 problems tops. You are expected to use computer tools like MathCAD, LT-SPICE, et cetera, to solve these problems. So effectively, if the problem is too hard for you to be able to complete with your peasant calculators that you're required to use because of that's what's available for the FE, I let you work more difficult problems outside of class and use any resource really except each other to knock out those take-home portion of the test. It's not, the problems there really aren't like, it's going to take an hour and a half for each one. It probably 20 to 30 minutes for each one. It just requires the use of a computer. So like the system of equations that you need to solve is too big for your calculator or something like that. I'm not just trying to throw some crazily hard problem at you. It's just, it's too difficult to do within the hour and 15 minutes. So I'm not, like I said, I give you a couple of days to do it. Honestly, the take-home portion of the test should take no more than an hour and a half to get done. So there's plenty of time for you guys to do that. And that will be submitted electronically as well. All right, let's see. Don't use a cell phone during your test while you're in class, or I will yell at you and probably fail you. Grades. Homework is 30% of your grade. Design projects are 10%. Each exam is worth 20% apiece. All of the homework assignments and design project assignments are weighted equally. I grade this class on a very strict 10-point scale. If you notice, an 89.99 is a B, meaning if you want an A, you got to earn it. There is no, oh, but I was so close. Don't care, you didn't make an A. All right, syllabus changes. I shouldn't need any, but if I have to change the syllabus, I reserve the right to do so and tell you what I did. Emergency notification system, boilerplate stuff, COVID-19 stuff should be on every syllabus you're getting this year. The important thing is this paragraph right here. If you are exposed or test positive or anything like that, you need to contact Miss Stacy Gilbert, whose email address is stacyc@lawtech.edu. You'll get assigned an SRT member who will guide you through the process of having COVID while you're on campus and let you know when you're allowed to come back to class, as well as fill out all the proper forms and all that kind of good stuff. All right, tentative course schedule. This is the winter quarter, which means we have 3 breaks, which drives me nuts because usually that means that everything that I've done before a break gets forgotten because you guys, I don't know, go spend time with family or get drunk or whatever. So exam 1 will be on Wednesday, January 13th. So we got about a week and a half worth of classes when we get back from the break to catch back up. And I tell you specifically when the take-home portion of the test is due, which is before the following class. Exam 1 covers the op-amp material and the transient analysis of RLC circuits material. Then we go into module 2 starting on Friday, January the 15th, which is steady state sinusoidal analysis stuff. Lectures 2 through 7 are largely review. 1, 8, and 9 are pretty new stuff. Exam 2 is on Wednesday, February the 3rd. That is before the last day to drop classes. So the last day to drop is on that Friday. So I will have your exams graded by that Friday, and the take-home portion is due at 11 a.m. that day so that I can use that afternoon to grade that part so that you can make an informed decision based on your exam grades and homework grades as to whether or not you need to drop the class. So I have it set up in such a way that you'll get all the information you need before the drop date. After module 3, as it were, the steady state sinusoidal stuff, then we get into the 3-phase circuit analysis, which is of course broken up by our Mardi Gras break, which means that all of the introduction stuff is going to get forgotten and frustrate the hell out of me when we try to move along when we return. And then exam 3 is on the last Friday of the quarter, and you turn in your take-home portion the following Monday, and we won't have class or anything like that. So that's the course schedule, the date for all of the homeworks, and I will probably update this with the dates for the design projects once I finalize what exactly I want to make you guys design this quarter. So are there any questions regarding the syllabus and stuff? Yes, sir. Pardon? Oh, they will be during the class meeting. So yeah, no, since there's only one section, there's only 11 of you guys, there's really no reason whatsoever for me to make you stay up at night and take a test in here. With regards to the format of the exams, in the past, I have done all, I guess you'd say like not multiple choice. I'm considering doing a short multiple choice section and then a few workout problems just because it'll make it a little bit easier for me to grade. But since there's actually, I was expecting roughly 30 to 40 of you because that's what I usually get. With only 11, I'll probably keep that up and it will just be full on questions where you can get partial credit and all that kind of good stuff. So yeah. But yeah, the in-class portion of the exam will be taken here in this room on the days specified. No night test for this class. Any other questions regarding any of the syllabus stuffs? All right. All right, so syllabus, we talked about homework, talked about MathCAD. So let's pull up that homework 1 assignment. And also LT Spice. If I can find it in this hot mess, I really need to clean up my desktop. There we go. I probably need to update it since it's been over a year since I did it, but not right now. All right. So your first homework assignment is 5 problems. I think 3 of them we'll look through. So this first one is Thevenin and Norton, kind of meat and potatoes, Thevenin and Norton, no dependent sources or anything like that. Ask you to determine the Thevenin voltage seen between the terminals A and B, determine the Norton current seen between the terminals A and B, determine the Thevenin resistance seen between the terminals A and B. And there's a hint here that in order to solve this, you're going to have to use the delta Lie conversion. That information is easily available online. It's a very, very simple resistor combination technique that for whatever reason I've been told specifically not to teach in Circuits 1. So I'm going to ask you to Google it and then apply it. It's not that hard. And if you have any questions about it, I'll be happy to answer them. Part D, verify your answers by using Ohm's law. And then part E, use a maximum power transfer theorem to tell me how much power this circuit could deliver to a well-chosen load resistor RL. And we'll get back to this in a second. Problem 2, Thevenin and Norton with a dependent source. Problem 3, independent source free Thevenin and Norton problem. So you'll have to use the test source method to solve this one. Specifically, I ask you to solve it using a test voltage source and a test current source. Problem 4 is an RL circuit with no dependent sources. And problem 5 is another RL circuit with a dependent source. So before we take a look at anything, does any of this seem too difficult? This is like the minimum level of you need to know this crap to be okay in this class. We're going to use Thevenin and Norton probably a whole heck of a lot, as well as basic circuit analysis techniques like nodal analysis, mesh analysis, KVL, KCL, but all those are kind of built into this as well. And then as far as the RL and RC circuit stuff goes, that's going to be our foundation for RLC circuit analysis. For the op-amp stuff, I would actually prefer if you forgot everything you learned in Circuits 1. It'll make my job easier. All right, so all of this seems, yes, sir.
Are you going to provide like basic answers for the homeworks, like referring back to like the freshman courses? They would provide like the questions and then they would give like this simple like numbered answer, just to make sure that we don't go through all the work and realize at the very end.
I honestly, I don't know. The reason why I say that is I feel like it's a slippery slope, meaning if I do that, then the expectation is, well, after it's due, can we get the solution, which means I can never reuse this homework assignment again. While I'm kind of okay with that, I'm kind of not okay with that too. I will seriously consider it, and I'm thinking for some parts of problems that will make sense, and for other parts of problems, it doesn't make any sense. So like these simple DC circuit analysis problems, that's not an issue. For some of the more complex ones, it will literally be giving you the answer. So what I'm going to do actually in a moment is show you a way that you can get the answers yourself using circuit simulation. So that's going to be another big part of this class, is simulating these circuits. And if you can simulate them correctly, you won't need my answers because you will have them in front of you, right? So let's take that first problem. All right, we got this guy, and we're gonna create it in LT Spice. I know you guys probably haven't had the opportunity to download it, that's okay. I don't know if I mentioned this earlier, but all of the Zoom, I'm doing the class concurrently in person and on Zoom. And as you can see, all of the Zoom things are being recorded. All of that will be uploaded for any and every student to have available. I don't know how many of you, I don't see that many familiar faces from Circuits 1 last quarter, but I'm going to try to do a much better job of getting all my stuff uploaded in a timely fashion instead of roughly a week after we did it, because I don't know, I was really busy. I'm probably going to be just as busy this quarter, but I feel like I can get it done. So anywho, so consider this a mild LT Spice tutorial. So got a big blank gray screen here. I'm going to have to go back and forth between this. All right, so I got some resistors. This thing is in the way of me dropping my resistors. Let me throw in my voltage source. By the way, LT Spice can do dependent sources and all that kind of good stuff as well. So there's literally should not be a problem in this class that you cannot use LT Spice to verify your answers on. And I'll put in all the component values in a minute, just trying to draw this dumb thing. All right. The current source was direction up. Should have brought my mouse. This would make it easier. All right, let's see. Resistor. A voltage source. And just a resistor on the other side. All right, so let's put in values for all this junk if I can. So let's, nope, that's not what I wanted. All right, so we got 20, 20, and then all the other resistors are 10. So to put component values, you just right click and type in 20. If you don't have to put in ohms, it automatically knows the value is a resistor is in ohms. If you wanted kilo ohms, you literally put the letter K. If you want mega ohms, you have to do capital MEG, because if you just do M, doesn't matter if it's capital or lowercase, it treats that as milli. So you have to explicitly say it needs to be mega in order for it to work. So this is a 20 ohm resistor. Notice that you can put tolerance values for your resistors and power ratings for your resistors so that you could build a circuit in here based on component values that you could get in real life, and it will randomly put the value of the resistor somewhere in that tolerance and tell you whether or not you're exceeding the power rating and you're going to burn it out. This is a very, very useful tool. It's used all throughout the engineering curriculum here, a whole heck of a lot in circuits, in senior design. So because it's way easier and cheaper to burn out virtual circuit components than it is real ones. So, you know, if you've got projects and stuff like that that you're working on for funsies, this is a good tool to use. No, 10, not 20. All right, so I got all my resistors, 20 volt voltage source on top, 30 volts on bottom. So one thing here, these are inherently a practical voltage source. So if you notice, you can put in a DC value and then you can also include a series resistance, which means it treats it as a practical voltage source or an ideal voltage source in series with a resistor. If we go to the advanced tab, which we're going to be using actually very shortly, we have an option of a pulsed voltage source, which we can use to do square waves and all that kind of good stuff. Sinusoidal voltage source, exponential voltage sources. I don't remember what SFFM stands for. And then we can do piecewise linear functions. So that means we can literally put in an algebraic function of different parts and it will string them all together to make a voltage source. We can also do DC from this menu as well. When we do our filter circuits, we'll be using the small signal AC analysis portion of our voltage source. Very, very powerful thing. So let's go back to just meat and potatoes DC. So this one's 20, this one's 30, and then our current source is 5 amps. And what I'm going to do now is I'm literally just going to put a little stub out here and a stub out here. And I can label these as VA. So this will, when I do my simulation, oops, I need to move it. So when I run my simulation, I can make it tell me the voltage at node A, do the other one to be the voltage at node B. And there are multiple different types of simulations that we can run, and I'm intentionally going to get an error here, but I'll tell you about it in a second. So we can use this to do transient analysis, which is going to be a large part of this class, AC analysis. So this is not steady state sinusoidal analysis. This is literally analysis where the circuit cycles through different frequencies depending on how you tell it to do that. So that is a very important tool in your communications classes and things like that, and in the design of filters, resonant circuits, antennas, and all that kind of good stuff, because it'll tell you exactly what frequencies you'll pick things up on and which frequencies will get rejected. Then we have a DC parametric sweep, so we can scale DC values to see how our circuit behaves as we increase voltages and things like that. We can do a noise analysis. We can figure out our DC transfer function, and then we can do DC operating point, which is the most basic, and that's what we're going to do right here. So a DC operating point literally says, this is a DC circuit, tell me what all my nodal voltages are, and then tell me what the current flowing through every single element in the circuit is. So if I press this little running man icon right here, it's going to give me an error. And the error it's giving me is that it says this circuit does not have a conduction path to ground. Please flag a node to ground. So LT Spice works by effectively doing nodal analysis on everything, all right? So you'll never be able to figure out what a mesh current is. You can only figure out what component currents are, and then you could use those to figure out mesh currents. So we just need to choose a ground. So I'm arbitrarily going to choose the bottom. And the reason why I'm putting this little stub of wire before I connect ground is, for some strange reason in some circuits, if I put my ground connected to that bottom rail there, it just kind of freaks out and gives me weird answers. So I make a little stub to designate that that is ground. So if I run my simulation again, it gives me all kinds of stuff. So it tells me what the voltage at node 1 is, and then the voltage at the node that I've specified as A is, the voltage that I've specified at node B is, the voltage at node 2, which is wherever LT Spice says node 2 is, the voltage at node 3, and then the current through I1, so that's our current source, the current through the various resistors, and the current through our 2 voltage sources. So we have all of the possible information that we could want. If I close this out, and this will be a little bit hard to see probably, but when I mouse over this at the bottom, it says right click to edit node VB. By the way, the DC operating point is 12.5 volts. So all of that information is now stored. If I were to mouse over this voltage source, it tells me the DC operating point, the current flowing through it is 125 milliamps. It doesn't tell me what the voltage is because it's a voltage source. That should be pretty damn obvious. But it also tells me how much power is being absorbed or supplied as well. So all of that type of information is already built into a DC operating point analysis. So in this case, what would my Thevenin voltage be? What would be the voltage here at node A, which is 32.5, minus the voltage at node B, which is 12.5, is 20 volts. Pretty easy to do, right? We can be even lazier. It's possible. If instead of doing a DC operating point analysis, I change my simulation command to a transient analysis. Nothing in this circuit is changing with time. Transient analysis to LT Spice just means I'm going to look at this thing over some duration of time. Doesn't really matter whether or not anything's changing. So I'm going to look at this for 1 second. And I simulate it. What I'm going to do is I'm going to add a trace because it shows you a blank graph because we haven't selected anything that we want to simulate. If I want my Thevenin voltage, which I know to be the potential difference between node A and node B, I simply tell it I want the voltage at node A minus the voltage at node B, and it gives it to me. I can do mathematical expressions in here, all that kind of stuff. So this is how I can check an awful lot of answers, even or especially on the transient analysis problems. I will ask you explicitly, hey, make sure you did all your math right by plotting this thing as it changes in time so that you can see, all right, I have my schematic representation and the simulation tells me what the answer is. And then I have my mathematical work and those curves should literally overlap if you did it correctly. So another thing that I want to go over here real quick with this, let me see, zoom to fit so we can make this a little bit larger. So when I mouse over a circuit component, this is a current probe and it's telling me the direction that the current is flowing. So if I clicked on this circuit element, it would put, let me move this thing out of the way so we can see. So it tells us at the top of our graph what we're doing. And by the way, I think the default is a black background, but you can change the colors and all that kind of stuff if you go into tools. You can change the colors, line widths, fonts, all that kind of stuff. It's very easy to do. Anyway, if I mouse over a circuit element, I get a current probe that tells me the direction of current flow that's considered positive. If I mouse over a node, I get a voltage probe, okay? So if I clicked here, it would give me the voltage at this particular node. And it's telling me right here that this is node 2. So those are the different types of tools that you have in a transient analysis. It doesn't give you the power, although if you wanted the power, you could simply multiply the voltage and the current waveform and get it. Pretty easy, right? All right, so that is using LT Spice. I want to do one more thing real quick. So let me kill this and enlarge this guy. So the second part of this first homework problem, this is the problem with this stupid thing, is that we need the Thevenin, excuse me, the Norton current. Oh goodness, what did I just do? Right, so the Norton current between terminals A and B, how I get that is I short terminals A and B out. Now, if I run a simulation, I can never get the current flowing through this chunk of wire because it considers that wire to be a node point, right? If I want current, I need a circuit element through which to measure the current. So how could I force LT Spice to give me the current? Anybody got any ideas? Yes, sir, or ma'am, whichever. Sure, put a resistor in there with a value of 0. Absolutely right. So I'm going to rotate it. Now, if I put one of exactly 0, let's see what happens. It might give me an error. I've changed the circuit, so I'm going to resimulate. Resimulate. Yeah, and it's not, so if I mouse over here, I get my probe. If I go over this component, I get my current probe. But when I mouse over this one, it's not letting me do anything. So instead of making it 0, let's make it 1 micro ohm, so 1 U. And rerun it. And now I get my current probe. So this is giving me the current flowing from node B to node A, as indicated by the direction of the current probe, which is going to be negative I Norton. So we see that it's negative 2 amps. If we wanted to make it positive, we could literally, since it's the current flowing through resistor R7 from right to left, we could go in here and right click, add trace, and do negative, sorry, I R7. And there we go. Now it's putting the 2 amp one up at the top that you can't see because this zoom thing is in the way. So you can flip the directions on anything literally by just plotting it and putting a negative sign out front. Real easy to do. For the Thevenin resistance, well, that's easy enough to figure out what it should be. You know what V Thevenin is, you know what I Norton is. Take the ratio of them, that kind of stuff. So you can use LT Spice for literally any and every circuit we're going to analyze in this class. Yes, sir. I honestly don't know the answer to that. I haven't seen any tools from like any multimeter tools or anything like that built in here. I think the easiest way personally would be to zero out all the sources and then apply a test source with a known voltage and then measure, or I guess if you put a 1 amp current and then you take the voltage drop over it, that will give you the resistor value. That will, to me, would be the easiest way to do it. The closest thing to a direct resistance measurement. Yeah, there may be something built in there to do that. I have been too lazy to Google it. So if you find something like that, that's fantastic, use it. So LT Spice can be used to check all of your answers, but it doesn't give you any information whatsoever on how it actually calculated anything. So you'll still have to do the work associated with the problems, but there's a way to check your answers for literally every single circuit we'll cover in this class. All right, anybody have any questions about anything else then? Now I know that you guys couldn't follow along with this or anything like that, but the video will be posted online, so you can go with that and then email me questions, all that kind of jazz. So, yes, sir. That is indeed absolutely free. And the MathCAD, it isn't free, but it is supplied by the university. So your technology fee and all that jazz pays for it. So I told you about a free textbook. You got a free software package to make your homework significantly easier. A lot of students always ask me, well, why didn't you tell us about this in Circuits 1? Because you wouldn't have to do any work. All your web work, boom, done. And then all of you would make zeros on your exams because you would get no practice actually doing the work by yourself. So anywho, so yeah, free, everything in this class is free except tuition, which is considerable. Yeah, sorry, not really. I like to get paid. All right, any other questions or anything? All right, so the roll sheet got floated around. If you showed up late and didn't sign it, please come up here to do so. That's all I have for today. So Friday, 11 o'clock, we start talking about amplifier circuits.